Okay, so this is the Trig lesson here, 1.1. So this is Trig lesson 1.1, chapter 1 on equations and inequalities. 1.1, basic equations. So, equations are statements with two quantities or expressions set equal to each other. Okay, that's pretty self-explanatory. We all kind of know what an example is. So we're going to start off small and then we're going to work our way up. Now, we all know what this is, and we all know how to solve these. So we're going to try to get all the x's onto one side, and then we're going to try to get all the numbers onto the other. So I like to try to make things positive. So since this is a positive 2x, I'm going to subtract a 2x on both sides. And the reason why I chose to do it this way is when these cancel out, 6 minus 2, I get a nice positive 4x over there. Still have the negative 7 here, and they still have the 5 left over on this side. So because I moved all of my x's over to this side, now I'm going to move all my numbers over to the right side. So since this is a minus 7, I'm going to add 7 to both sides. The 7's, as you can see, cross out. So all I have left on this side is a 4x, and I don't know why I crossed that out, but we have a 12 left over on that side, so 5 plus 7 is 12. So 4x equals 12. So because this is 4 times x, I'm going to do the opposite, which is divide by 4. So remember, you always do the opposites here. Minus, so it's plus. Plus, so it's minus. Here's multiply, so that's why I'm dividing by 4 to get x by itself. And x equals 3 is your answer. So, just showing you here, you could do this another way. If you wanted to, I could have subtract a 6x from both sides. Those cancel out. I have a negative 7 left over on this side, and a negative 4x and a positive 5. Because I moved all my x's over to the right, now I'm going to move all my numbers over to the left. So because this is a positive 5, I'm going to subtract 5 on both sides. The 5's cancel out, leaving me with negative 7 plus negative 5 is negative 12. Negative 4x left over on this side. So because this is negative 4 times x, I'm going to divide by negative 4 on both sides. And when I do that, negative 12 divided by negative 4 is 3. So this is just to show you that either way you decide to start this problem, you're still going to get the same answer. Either way. Okay, so with a problem like this, it stinks because you're going to do a lot of work, but it's really not that challenging. Basically what you need to do with your first step is we're going to need you to FOIL each side of this problem. Okay, which is what it's going to take forever. So I'm going to FOIL this side first. 8x times 3x. 8 times 3 is 24. X times x is x squared. 8x times 4, that's positive 32x, because the x comes along for the ride. Negative 2 times 3x is negative 6x. Negative 2 times 4 is negative 8. And then we can combine our like terms. I have 32x's minus 6x's. So I actually, on this side, after I'm done foiling, have 24x squared plus 26x minus 8. But now I need to FOIL this side. So 4x times 6x, 4 times 6 is 24. X times x is x squared. 4x times a negative 1 is a negative 4x. 3 times the 6x is 18x. 3 times negative 1 is negative 3. Once again, I combine my like terms, negative 4 plus 18. So I end up having a 14x on this side. So now this is everything FOILed out. So now, just like the last problem, you need to combine things that are alike and get them on one side or the other. So what I'm going to do is, I realize, hey, I have a positive 24x squared, so I'm going to move it over here with this x squared. And what you realize is they both end up canceling out. 24 minus 24 is 0. 24 minus 24 is 0. So really, all you have is 26x minus 8 equals 14x minus 3. So to get all the x's by themselves, what I'm going to do is I'm going to try to make them have positive x's if I can. So I'm going to subtract 14x on both sides to get rid of this over here. And 26 minus 14 is 12x's. I have a negative 8, and on this side I still have a negative 3. So that's what I'm doing here with that last step there that you just saw. I'm actually looking at this problem saying, hey, I moved all the x's over to this side. So why don't I move all the numbers to the right? So that's why I'm going to add 8 to both sides. So the 8's now cancel out. Negative 3 plus 8, that is a 5, and I still have the 12x left over on that side. So it's 12 times x, or the opposite of multiplication is division. So I'm going to divide both sides by 12, and you end up with 5/12 as your answer. Okay.
Oh, a graduate student, huh? How come you guys can...
Okay, so we're looking at another problem here. So let's take a look here. I'll do this one more example here. To do this problem, you get things that are alike together on the same side and all that wonderful stuff. But if you notice here, I have a fraction. Over here, I have a fraction with an x in the bottom. This isn't. So I can choose to A, find a common denominator of everything, and then I can basically add everything together and try to solve it. Or if you notice, these both have x minus 2's in them. So if I wanted to, I could combine them both on one side together if I move everything. And that's what I'm going to do here. If I minus this fraction over to the other side, right? Now this is gone over here. It's no longer there, right? Because I moved that whole item over. And the reason I did that is because now what I have is I have a 3x over x minus 2 minus a 6 over x minus 2. Because the bases are the same, just like any other fraction, I can add them together. So really, when I move that over, this is what I get on the left-hand side, a 3x minus 6 over x minus 2. And that equals 1. So by me moving this over and making them, which they already do, have the same denominator, I can just subtract the tops right across, just like any other fraction, and leave them the same on the bottom, which is what I did. And this is the new problem that I have. Well, this is a much simpler problem to solve, right? When you want to get rid of that fraction on the bottom, all I need to do is multiply by the reciprocal. Well, x minus 2 is on the bottom, so if I multiply both sides by an x minus 2, now the x minus 2's cancel out over here. So I'm left with 3x minus 6 on this side, and 1 times all of this will just give me all of that, which is x minus 2. So really, this problem was just 3x minus 6 equals x minus 2, which is a very simple problem to solve. I'm going to subtract an x on both sides, because if I do that, the x's cancel. And 3 minus x is 2 x's. I still have a negative 6, and I still have a negative 2. I'm going to add a 6 to both sides, because remember, if I move my x's to the left, I should probably move my numbers then to the right, which is what I'm doing here. So my 6's cancel out. I got a 2x. Negative 2 plus 6 is 4. So 2 times x, that means the opposite of multiplication is division. So I'm going to divide both sides by the 2. So they cross out. 4 divided by 2 is 2. So your answer is x equals 2. When we come back here, I'll try to finish up some more examples on some basic equations and solving some stuff in section 1.1.